Good morning, everyone. Welcome to Contactless Future Experiences with UltraWideBand Technology session. My name is Turbek. I am part of the team that leads emerging business initiatives at Futurists. And our mission is to research new technologies, industrial trends, design trends, and we do that in order to help our clients to build commercially scalable business processes or models. So right now you are visiting our bi-weekly community coffee sessions. This is where we talk about the outcomes of our work with the rest of Futurists. And just so you know, we recently opened this community to the outside world as well. So if you're interested in being on top of what's going on around the world in terms of technology, design, and business, you're very welcome to join the community. Just let me know. I'll add you to the mailing list and you can join whenever there is a topic of interest in one of those Friday sessions. And you can hear this very seldomly probably from a client. It is indeed free of charge because we love to share. So back to the topic. Most of you already know that, and I think I work with you even in some of the projects that I am making. I am passionate about making future as contactless as possible. In terms of digital interactions. And back in the day, we worked with technologies like biometrics and computer vision. And although I believe biometrics did reduce the number of interactions that is needed to interact with the technology, especially through our phones, when it became mainstream after the launch of Face ID and other biometrics technologies that works locally on the phone, it came short for making a huge impact during the interaction when we are in the physical world. So the services and technologies that we interact outside of our phone, technologies like biometrics and computer vision haven't yet fulfilled their promises. But then there came UWB, a radio technology that likes of Apple, likes of Volkswagen is already being employed. So we had to investigate. And so we did. Over the course of summer, we basically collaborated with Kasperi and Iivo from Aalto University to explore what it means in terms of end user identification, localization, tracking, and other contextual use cases like payment. We did that in the retail area, but the lessons can be easily extrapolated to other industries where these kind of applications can actually disrupt how the user experiences work. So without further ado, I am going to hand over the stage to Kasperi and Iivo, hoping that they are already here. So feel free to share your screens and get the show started.
Yep. Hello, everybody. My name is Kasperi. I'm a fifth year robotics student at Aalto University and have been participating in the ProtoCamp course this summer, doing stuff with UltraWideBand and seeing what it can do in a contactless environment. So our project is called Rapid Card. But first, let's talk a little bit about what is ultra-wideband technology. It is a radio technology similar to Wi-Fi and Bluetooth, and it utilizes low energy and high bandwidth for short-range communications. And the kind of party piece of UWB is accurate distance measurements, which can be used for many different kind of applications. On the right, you can see the signal spectrum. In terms of power, it's very low power, but as the name suggests, it's a very wide frequency band, which helps in many ways. The benefits are that it's ultra accurate. One can achieve centimeter accuracy. And it's also very reliable and is somewhat immune to obstacles in its path, and interference from other signals. It's also real time.
The benefits are it's accurate, as Kasperi said. Our kit was marketed to be up to 80 meters with 10 centimeter error margin, and it's ultra reliable. It's used in multiple security systems or which need security, and real time it updates the interval between the updates is milliseconds, and affordable, of course. It's low power, low cost, low processing, and secure, as I said. It's hard to intercept the signal and hijack it, as in the near field radar, which is used in the lähimaksu or contactless payment nowadays.
Iivo, quick question because it's really important. Let's clarify that a little bit more. So basically, you mentioned the centimeter accuracy, and then you mentioned 80 meters. 80 meters refers to the distance where kind of how far you can be from a UWB base station to be accurately detected, right?
Yeah, but we found out that it wasn't that accurate, at least our kit. But it should have been to 80 meters with 10 centimeter error margin. But we came to the conclusion that with multiple base stations, it could become much more accurate, and the location tracking would be really good.
Yes.
Yeah. Up to the next slide. Security. For example, Asa Abloy is developing smart locks with UltraWideBand technology, not only because it allows secure connection, but the distance and location to the door is possible to find out because of the location tracking. Location tracking, it has multiple use cases, and then contactless payment takes advantage of the location or distance measurement and secure data transfer. Then industrial real-time tracking can use precision location tracking for fully automated warehouse control. Smart home is a great example of vast possibilities. You can have multiple devices on passive control based on your location. For example, lighting, doors, coffee machine, and stereos. And lastly, in the health and fitness, UWB can provide reliable movement information without a physical connection. It can detect even 4 millimeter movements, and over time it can help detect illnesses preemptive based on the data received. This health and fitness information, I found out there's a company that does this kind of work with UltraWideBand. So with our kit, it wouldn't have been not so possible to do that. But with some extra hardware, it would have been. So out of these potential applications, we chose the contactless payment, and we added in verification or membership verification.
We decided to do contactless payment with loyalty member recognition. In our case, student card recognition, but it could be any type of loyalty card, theoretically. So next is a video. The idea is that you walk close enough and your loyalty card or student card gets recognized from a database, based on that UWB device that you're holding, whether it be a smartphone or, in this prototype case, the UWB tag. And it shows the distance to the user and also the student card. And if you walk closer, then it authorizes the payment automatically. So in this case, the payment would be the standard amount for student lunch, which is easy to do, completely contactless. So the hardware is on the right. On the top, there's the UWB anchor or base station. And on the bottom, there are these UWB tags, which are kind of sort of passive in the way that you can connect to them and relay the distance information to them. But most of the code work was done on the anchor and base station / PC side. But the kit is used, in our case, for the contactless identification and payment using distance measurement. And the UWB tags simulate smartphones. Actually, some newest phones already have UWB enabled, like the newest iPhone and Samsung phones. And Apple also has those AirTags, which you can attach to, for example, keys. And so if your keys get lost, you can easily find them using your phone, even using the camera to guide you to your keys. But yeah, the UWB implementation on the actual hardware is written in C, and the PC console software and UI is in Python. The actual program is pretty simple. It's basically 4 states called scan, identified, not identified, and pay. And there's also some transitions on how the program moves between those states. So it initializes in the scan state and continuously monitors this event queue, which contains the identification of the tag and also the distance to that single tag. And if it detects that it's under 2 meters away, it checks a database whether that tag has a valid student card. And if it does, it moves into the identified state where it displays the photo and distance to that tag continuously. And if the user walks within 1 meter, the payment is automatically authorized. And then when the user walks far enough, in this case 2 meters away, the program transitions back into the scan state to allow new customers to pay. And this works so that once a single tag is under 2 meters, it blocks all the other tags from entering and getting identified. So there can only be one tag at a time in the payment process. And also, if the valid student card is not found in the database, it displays that also and doesn't allow the payment. So next is our full product video. Yeah. So as you saw, it was filmed in a actual cafeteria and simulates the actual use of this proto. And as you can see, for standard sized payments, it makes the whole payment process extremely fast.
We have one question in the chat. I think it's referring to the hardware part. It's about the size, but what is the size of the components?
The tag is about 6 millimeters. 6 centimeters long, couple of centimeters wide.
So I just wondered, can you incorporate it in just kind of a credit card format, or what would the end user get to identify, and how much would be the cost? Because I think this is quite crucial for applications to see, can it be easy incorporated into something, and will it be cheap for the service provider to distribute it amongst the customers?
Basically, the idea is that everyone would have UWB in their smartphones already. So it would be just to download an app where you have the membership card ready. If you have UWB on your phone, there's no need to buy any hardware. I think to make a actual physical membership card would be pretty tricky, because one would have to fit a battery inside that card, and it's pretty thin.
To add to that, Kasperi's comment, I think the promise of UWB and the potential of it will be fully realized when the technology becomes even more mainstream. As said, like Apple actually has the in the top line phones, it comes within the phone. Same goes for Samsung. Apple Watch, the latest model, has the UWB enabled as well. So that is when actually the full potential of UWB realized. Until then, we see examples. For example, what you asked, Marcus, I think Volkswagen is a great example for it. Volkswagen is integrating it into the car keys. So the tags that is for multiple uses, hands-free access to car, identifying the user, drive-in payment. These are all use cases for Volkswagen, and the tag is kind of embedded inside the car key. And I think either Kasperi or Iivo mentioned the Abloy case, which is they are doing the kind of again, the key is the where the tag is. And I see some questions around the pricing. Right now the UWB tags and base station, for example, from our partner NXP, it's about $100 per unit. This set that the Kasperi and Iivo have used. Not exactly this set, because this is a development kit that has a lot of material, etc., some training sample codes, yada yada. But the actual hardware costs about $100 per unit.
I like to add that I think, Tuber, you didn't mention that also Apple AirTags are using UWB already. So that's like probably around the size that's reasonable for like actual real world use with like battery capacity. That's enough.
I think there's one quite freeform question asking, like, can you put it in a basketball and do a game?
Well, yeah, they use it in NFL and in NBA, actually. The UltraWideBand technology to track the location of the football and the players. But I don't know how small their devices are, or they must have some different devices, or smaller and more compact and more durable and built in the basketballs.
So it's important they highlight the difference between distant measurement and localization. So what the guys did was distance measurement, and this is something you can do where like the kind of the base station is static and people are approaching to it, people with tags. But if the goal is to triangulate and localize where the object is in a physical space, then you would need more than a single base station in order to be able to do that.
Yeah, and UWB also has this angle of arrival technique, so it can be used to measure the angle to the UWB tag, which is actually used in the Apple AirTags. But in our kit, there was a lot of noise in the angle signal. So if the tag was 5 meters away and the angle had 30 degrees of angle noise, either way, we couldn't use it for like localization. So we would have needed another anchor to triangulate based on the distance measurement.
Maybe also talking about the potential. So if we could maybe ask also in Germany, we have now connections to Hammer from the gym and sports industry. And just thinking about going to the gym where you have already machines that already recognize you, but still it's, I think, basically with a card. And if you add there your smartwatch with health information, you get a nice profile of your body's activity and so on. And I think there might be a quite cool market. So maybe we could think about exploring this market, or did you already do something like that in Finland?
No, actually, I'm going to be honest. When I saw health and fitness in Iivo's deck, I immediately thought of hospital use cases such as like patient recognition, tracking of the assets at the hospital, like beds and etc. But yeah, what you say makes a lot of sense, Marcus. Like the fitness side of things.
Hey, I would like to ask, like from Kasperi and Iivo, like now when you had this project, was there something that really like surprised you, like you didn't expect, or some really new findings or interesting problems or something surprising?
Well, in the first stages, when we first received the kit, we had super high hopes for it, but it didn't perform to the level that we expected, like the 80 meters and 10 centimeter error margin. It was just too good to be true. So we had to think about our use cases based on that. But after we got used to the devices, and we found out that with multiple base stations, you could triangulate the location, and in store, like the payment would happen inside a store, so it would have multiple base stations. So yeah, we basically got the idea of the
Yeah, I think most of our surprises were related to the actual hardware we got, and not necessarily UWB in itself. But yeah, Dennis raised his hand.
Yeah, maybe a couple of questions. One is how open is Apple to apps using UWB, and can you use it in the background, or do you need to have the app open? So can you do it with no interaction at all? And maybe the second question is how commoditized is the hardware? Is it ready to be rolled out on a larger scale already, or is it still developing?
Well, as I have understood, Apple has developed their own UltraWideBand, like secretly, so nobody knows their technology. At least the videos I have seen from their newest iPhone, searching for a AirTag, the augmented reality, or the through the camera. It shows pretty precise the location of the AirTag, but I don't think. Yeah, I don't know an answer to the rest of the questions.
Actually, I checked some Apple video recently, and they do support at least like third-party hardware. So, for example, they mentioned NXP as a partner for the UWB hardware. But the thing that I also don't know is that if you can track it actually in the background. I hope so, and it would make sense that you can do it, but I'm not sure. So it has to be checked.
Okay.
To your second question, then is like you can source the technology from NXP right now. You could place an order and get NXP kits, NXP UW kits. Obviously, the question becomes like when is a good time? Is it we wait more and more phones to adopt the technology so that it comes out of the box, or actually go the way Apple goes about it, which is creates this additional hardware with the AirTags and whatnot.
Yeah, I unfortunately don't have the resources that Apple has to produce my own hardware. We're a bit below that level. I've noticed in the last few weeks that even quite commoditized hardware does not fare well when water is coming from below and above and fills up everything. So I would be quite hesitant to put a lot of this outside if it's not something that I can buy off the shelf. It's easier to fix software than hardware once it's deployed. But very, very interesting stuff. And
Well, I'd like to thank Tuber and Mikko for great assistance with the projects.
We thank you for the good work that you have done, and I think what you put out there is very exciting and promising from technology point of view. So good job, and thank you everyone for joining the session. Hopefully see you next time.
okay.
Thank you,
everyone.